Welcome back. This is where I left off. We were talking about the resultant vector. This is the symbol for the resultant vector. That symbol stands for sum. So that is the sum of the two vectors. And in this particular case, the sum would be square root of a squared plus b squared, which comes from the Pythagorean theorem, because the Pythagorean theorem, as you taught in your math classes, are c squared equals a squared plus b squared. Here's another example of vector addition, example number 4. So if I have two vectors, vector A is pointing to the right, vector negative B is pointing down. If I'm adding vectors A and negative B, I'm going to redraw them so that they're touching head to tail. And then this would be the resultant vector. This would be A plus negative B. So if vector A is 4 meters per second and vector B is negative 2 meters per second, this would be the resultant 4.47 meters per second. And once again, we're going to find out the direction by finding out this angle theta, and that is going to be part of the end of this video, and you can find the angle theta here also. We'll talk about that. That'll be some food for thought. So I'm going to switch sheets here and talk to you a little bit about vector subtraction. It's not very difficult. If I have two vectors, A and B, but this time I'm asked to subtract vectors A and B, so I'm asked to do A minus B. What you'll notice is I'll just flip vector B around, and I will, if it was pointing towards the right, and I'm going to make it point towards the left, and then I'll just add them together. So the resultant vector would look simply like this. This would be A minus B. Example 2, if I have two vectors, or vector A is pointing to the right and vector negative B is pointing towards the left, and I'm asked to subtract the two vectors, A minus negative B, I'm going to flip negative b around because it's a subtraction problem, and now it points to the right, and I place them head to tail, and this would be the resultant of the two vectors. So you're going to see a lot of patterns here between vector addition and vector subtraction, and you're going to see a lot of patterns between your physics class when we're discussing vector addition and what you learn in math class, because you'll notice a negative and negative becomes a plus. So this becomes a plus b, and this answer looks a lot like that vector addition problem we did, example we did earlier, when A and B were pointing in the same direction. Same for examples 3 and 4. Vector A and B are being added together, but A and B are here, and you're being asked to subtract them. Excuse me, I said added together, but I need to correct that. If you're being asked to subtract the two vectors, all you're going to do is take vector B and you're going to flip it around. If it was pointing up, now it's going to point down, and you're going to put them head to tail, and this guy right here will be the resultant vector. Same for example 4. If vector A is pointing towards the right, vector B is pointing down because it's negative b. If you're being asked to subtract the two vectors, you're going to take your negative b and you're going to flip it around, and now it's going to point up, and this will be the resultant vector. So hopefully you're going to see some similarities between vector addition and vector subtraction, and also you're going to start to see some similarities between your physics class and your math class. So here are two practice problems. In practice problem 1, this is my home, and Mr. Parvez walks 4 meters to the right, and then he walks 2 meters again to the right. The question is, please draw the resultant vector. So first you're going to draw the resultant vector by placing these two head to tail, and then I want you to show me how many meters Mr. Parvez has actually walked. So tell me my total displacement. That's very important. I want you to draw the resultant vector and show me the total displacement from my home. The second example is from a bird's eye view. If this is my home from above, and I walk 8 meters to the right, and then I walk 4 meters up. So for example, I'm moving 8 meters east and then 4 meters north. I want you to go ahead and draw the resultant vector and show Mr. Parvez's displacement from his home. Show how far have I walked from my home. How far am I now positioned? Where am I positioned compared to where my home is? So I want you to try both of these practice problems, and if you have questions on these practice problems, make sure to attend one of our office hours, and hopefully I can answer some questions for you. Now, before you go, here's some food for thought. I want you to take a look at these vector drawings. This is vector A, B, and C. You can notice that I've gone ahead and broken these vectors up into their x and y components. So now I'm doing the reverse of what I did earlier. So if you have a vector that's pointing in this direction or this direction or this direction, this is how you break them up into their x and y components. So take a look at this and put this in your notes. This is just a food for thought, as it will show up in our following lessons. There's also some more food for thought right here. If you have to find the direction of a vector,